Hi, so I'm Raymond from Eurocom. What I'm going to show you here is a little bit, some of just a bit about the equipment that we're using to build this cloud run playground and experiment with some of the front-haul technologies that we're looking at. So if I just do a quick tour of the stuff we have here. Down here I have a commodity Dell server. This is a 20-core Xeon server, second generation. It'll be upgraded to more recent Intel components when we deploy the full solution. This is just being used to test the basic components. So this server is running actually the CRAN fabric, if you want, here. This is connected to a front-haul network, which is there on the desk. You can see here this is 20 meters of optical fiber to interconnect the server with this off-the-shelf Cisco switch. So this is an aggregation switch. It takes 20 gigabit Ethernet in and pushes out 1 gigabit Ethernet copper links with power over Ethernet. And so this is one of the links driving the remote radio system. So this copper goes into this power over Ethernet power generator to power up the electronics and to provide the 1 gigabit front haul into the remote radio unit. So here the remote radio unit is a Pico ITX module with a quad-core Atom running at 4 times 2 gigahertz. It's connected to an off-the-shelf USRP via USB 3 and just a duplexer for the front end going to the antenna. And so this is a single antenna remote radio unit. Now we're testing different kind of components. The smallest one we found is this very recent board called a UP board or an UP board. It's more or less the same as this Pico ITX, but in a Raspberry Pi format and lower power, which will combine with a board such as the USRP and a power module, which will put out around half a watt transmit power. And so these will be the basic components that'll be deployed here. So just to show you this is actually running, I have a smartphone here which is in airplane mode. I can turn it on. And here you can see on the screen that the Cloud Center has reacted and actually is playing the role of the eNode B. I just run a quick application here on the phone just to convince you that it is actually running an LTE signal, where you can see open air interface there.
Forget about the demo. The demo is not important because you are using that in the first one.
For Christmas, we will be deploying 20 of these radio heads in our building here, and towards the middle of next year, we'll ramp it up to 50 or more radio heads, so that we can actually play around with these technologies in a scaled environment. So this is part of Open Air Interface Alliance Project 4, which deals with cloud run architectures, orchestration, software-defined networking for deploying telecom networks in a data center. We're looking at working closely with groups like the ITU and the NGFI in order to do proof of concepts using this technology and get input from other open source communities, tools like the stuff that's going on in ONOS or in OPNFV, that sort of thing, combining it with these access technologies to make a real proof of concept of future cloud run systems.